What are large language models? They are, think of a massive system, a deep learning algorithm, an evolution of that, which is what transformers algorithm is all about. And a model that can understand natural language like English that we speak or any other language. Obviously, now we have multi-language support as well. And then it is able to produce an output which is also in natural language. So that's what simplest example of a large language model, right? It can take an input in simple English and it can provide an output in simple English. And compared to a database, for example, it can only accept structured query, like SQL, uh, structured query language is called SQL. And then it'll be able to produce an output, which could be a table, which could be a data set, etc. But large language models is very unstructured that way. And how they work, and this is fascinating, they are also dubbed as the next best word predictors. So they always predict one word at a time. And that is how they form a sentence. So there is this concept called attention, say multi-head self-attention or masked attention or cross attention, etc. We'll discuss about that. Those are technical terms. You can like speak to someone, you can drop these terms and obviously get some brownie points, but they are actual serious technology in the back end. So if you see um, LLMs predict one word at a time, and they're next best word predictors, which is why there are a lot of, I mean, when people speak about, hey, LLMs have reasoning power, probably they're not reasoning. They are now smarter to probably produce your next best word, which you are able to relate to. So that is how kind of the other side of the world looks at it. But we don't have to kind of get into that debate at this point in time. LLMs are next best word predictors. And why they matter for agents? Because when you bottle this so-called genie, the LLM, into an agent, you are able to have a human-like software which can now interact with other systems within an organization. It can reason, it can execute tasks, and it is not hard-coded, which is where agents really kind of become very powerful. For examum, at Lyzr, we do have machine learning agents, we have code agents, we have data agents. There are various types of agents. The LLM agents are the ones which are by far the most popular one. And when you look at this, when it comes to machine learning agents or the code agents, they are agents, but they are governed by very strict kind of hard-coded rules in the back end. But when you go to a large language model agent, they are not. They are just instructions. And you will see in the next few sessions when we actually practically show you how the agents can decide and think and play around the tools and the other agents it has, you can kind of really see the power that these LLM agents bring to the table because you're not tied to hard-coded workflows. And and with that, obviously, with reasoning LLMs and multimodality coming in, they are further increasing the chances of LLM adoption or AI adoption in an organization. So the diagram here is pretty easy to understand. If you look at it, LLMs accept prompts or inputs and they tokenize them, and then they are able to find the embedded or the relevant vectors, and it's able to bring the answers back to you because it predicts the one word at a time. Now, going further, yeah. What really changed was this paper that the Google DeepMind team wrote back in 2017. And this is a paper where attention, they spoke about attention. And that was the very first time the Transformers architecture was shared. And what you see here is what a Transformers architecture looked like. This is the core of a large language model. And again, I know there are a lot of product folks, non-technical audience here, but I'm trying to still explain as simple as possible. So please bear with me. But next time when you see such an architecture, you will not be startled. You will understand kind of what is really happening, at least at a high level. So what you see here is there are two aspects. There is encoder and there is decoder. So the encoder's job is to understand an input and prepare the input for the decoder. Let us give an example, right? Imagine you are trying to do a, say, English to French translation in a simpler layman's term. That's not exactly how it works, but for you to understand, when English is the input language and the encoder's job is to understand and prepare the input so that the decoder can now create a relevant output for the same. So, what really happens behind the scenes is a concept called multi-head self-attention. So, like I mentioned earlier, it's all about word by word. So, when you kind of give a sentence, right? Okay, hey, how did it go today? So, how did it go today? These are five different words, and now the LLMs starts, the encoder primarily starts looking into it. Okay, what are these words? And it starts assigning weightage. And it doesn't only assign weightage to a particular word, which is called a token. Tokens are kind of sometimes one single word can be divided into two tokens or three tokens. There is again no definitive library to kind of to give you an idea of how it will be divided. But long story short, the words are given weightages, and each words now also know, I mean, the encoder's job is to also give a comparable weightage as well. Okay, what is the next word? What are the other words in the whole sentence? Which now allows the decoder to find the relevant next word or find the next best word from its pool of tokens. You would have heard about concepts. Sorry, when LLM say 128K tokens, Google says 1 million token context window. So that is the context window from which the decoder picks the next word. But it's encoder's job to do its job really, really well for the decoder to come into picture. So this is, you can obviously read a lot about it more on paper, but what you really have to know about is encoder prepares the input for the decoder to do its job, and, and this is where it all started from a large language model perspective. Now there are various types of LLMs. This now gets interesting because we've done with the difficult part of it. Yeah, there are a lot of aspects. Like I can speak about how decoder uses say masked attention to begin with, and then also uses cross attention, and then how the contextual embedding come into picture. But I'm not gonna bore you with that stuff. Just please remember, it's encoder and decoder. Encoder's job is to prepare the input so that the decoder can look into it and pull the relevant data, pull the relevant words, the next best word, so that it can prepare the output for you. And it all started with OpenAI, as you know. GPT-3 came out, then 3.5 came out, which really is when things started really getting better. And now we have a lot of choices. We have the frontier LLMs, also called as closed source LLMs. You have GPT, Claude, and Gemini leading the way. You have some fantastic open source LLMs. Llama by far is the market leader, closely followed by the newer NVIDIA models and also the Mistral models. And then you also have the SLMs, the small language models. I'm a massive fan of Phi. Now we had Phi and we have Phi 4 also now come out with from Microsoft. I really love the model. You have Gemma 2B that Google released, which is actually a gem of a model, to be honest. GPT, I believe OpenAI I believe is preparing a small model as well to be launched shortly. When these models were there a few months back, we had the reasoning models come out. While Sam Altman has been speaking about reasoning for quite some time, it was the moment was when DeepSeek really came out, when they showed what reasoning means, how the models are able to think. And if you go and play around with Manas AI or DeepSeek, or even the latest ones from GPT like 4.1 or even O4, etc., now they all follow the thinking process where they're showing you. But it all started with DeepSeek to really show the world how the reasoning behind the scenes kind of actually work. So these are choices. We are spoiled for choices, but I can also throw in what we are seeing in the market. Larger organizations are still using the frontier LLMs like GPT and Claude and Gemini, but interestingly, not for a lot of their core functions. Um, LLMs are getting commoditized very fast. I mean, I'm not able to see a massive difference between using a GPT-4o, which is a model that came many months back, in an enterprise scenario. Because when it comes to enterprises, they are not necessarily working with, say, internet data or third-party data. They are working with their own data. And what's more important is how these models could be used with their internal data. And when you think about it, GPT-4o still holds good for a lot of these scenarios internally. We do use some reasoning models sparingly, but most of the workflows within these organizations are not very complex. They do not need a lot of reasoning. They don't need a lot of cognitive power, even from humans for that matter. So hence, the trend that we are seeing is organizations are kind of leaning towards using open source models, but they run on compute like Amazon and all these larger platforms, Azure's and Google's for compute. But they do kind of lean towards open source a lot because they can fine tune, that becomes their IP. They can keep these models with them. So that is how at least the trend that we are seeing. But when it comes to startups and SMBs, yeah, hosting and running all this fine open source models is a pain. So it's easier to use models directly from OpenAI or Anthropic. We are like internally massive fans of Claude across the organization. I can say that for at least the engineering side, the GTM team might have a slightly different opinion. And I mean, we have our own favorites, right? Because we are in this LLMs, I'll probably take a bit more time on this. For example, anything around OCR, like document conversion, Gemini is like far better. We've deployed a lot of production systems, and we've seen that Gemini is like hands down the winner here. Mistral did launch a recent OCR friendly model, but when it comes to Gemini, we don't even have to train you, and it's mostly accurate most of the time. So we have our favorites when it comes to coding, code generation, SQL query generation. We kind of rely on Claude. When it comes to even agent building, right? So we are building an agent that can build an agent, by the way. So when we looked at that reasoning again, we kind of like Claude a lot. GPT is like the general purpose for us. That is like the, say, all-purpose flour that you have. Do whatever you want, bake a cake, do a roti, and whatever you want to do. So that's like GPT. Always you can fall back on it. So these are some of our, I would say, uh, favorites internally, and also when we go to customers, we kind of see similar scenarios as well.